it's time for you to see the very first thing I'm using some of the zinc for. The zinc from my unboxing video. The first thing I've made here is a zinc canister. Now, of course, the canister turned out not to be totally zinc, and the reason why is because there was a casting imperfection in the piece I used to make the lid, so I had to bore that out, and I made a magnesium plug. So it's not totally zinc, but mostly zinc. The magnesium machining here, what little of it there is, was at the end, and it's actually pretty fun. When I was working on this project, I mostly focused on just figuring out how to do it. So I didn't film everything. I filmed as much as I could. Whenever I had a moment when I wasn't focusing on figuring something out, I would film, and I filmed quite a bit of the process, but not quite all of it. So there are some gaps in what I have covered by footage. How much of it I was able to film was much greater in the second half. Also, I got my iPhone X somewhere in the middle there, so the footage is much higher quality at the second half. The first half is still fun, and it contains a lot of important information in order to understand what's going on in the second half, but I had to use my laptop webcam because my old iPhone wasn't working, so the video quality isn't as good, and I was also focused on figuring other things out. Now, the one exception to the webcam footage is when my friend Rex, whose shop I was using, filmed some of what I was doing towards the beginning, so that footage is good. But the majority of the first half is webcam footage from my laptop, and it's not as good quality. Also, before my old iPhone failed, I did get a little bit of footage myself. So when there is a significant gap in what I was able to film, where I completed like whole steps without filming anything, I'll come back in front of the camera here and explain what happened to make the transition clearer. The first thing that we did was we melted down 4 of those ingots of zinc that you saw in my zinc unboxing video to make a cylindrical casting. Now, we didn't pour it, we just took a can and melted down the zinc and then let it solidify and cool in the can. I didn't film most of it, but towards the end, right as we finished heating it, I did film a little bit, and you can see some of the torches we were using to heat, and you can also see the liquid zinc. So here's that footage.
It's good, Sam.
Yeah, it works for me.
We left it up.
So now you've seen a little bit of the zinc casting. Now what we did then is we went in and drank tea while it cooled. It turns out it took a really long time to cool. When we came back out, it was still actually quite hot. It wasn't liquid anymore, it had completely solidified, but we had to roll it around in the snow to get it cold enough to handle. Now, interestingly, and somewhat unsurprisingly, the sides solidified first, and this caused a hole to form that was like an inch or so deep. So then we decided to make that not the bottom, so that then we would get it all drilled out and bored out. And this didn't affect the body because we were just drilling it all and boring it out. The same effect happened when we made the blank for the cap, but since the cap wasn't going to be drilled out as a container and it was much thinner, that actually did end up becoming a problem, and that's why the plug was needed. But, of course, before we could even get to the machining, we had to get the can off. So this next clip is of me feeding it into the bandsaw blade to get the can off.
Is it going?
It's going. Okay. Let's get the can off.
I think I got it all. Yeah, I'm definitely into the zinc.
The next thing I did was I used pliers to peel the can off, starting from that cut. It peeled off really nicely, the zinc did not adhere to it, and then I mounted it in a 3-jaw chuck and started machining it. I put it in first with the bottom towards the chuck and flattened out the side with the hole in it, and this was just a rough facing so that I could flip it around, face the bottom, and get a really nice face on that so it would seat against the chuck really nicely and sort of form the reference surface for the whole machining. The next clip shows me facing the bottom.
So here we are facing off the ends. This is going to be the bottom, then we'll flip it around and bore out the middle. We'll drill it out and then probably use a boring bar to get it to the final radius. It took a while for this thing to cool. Such a bulk of metal, surprisingly long for it to cool down. The machine's like butter. Pretty ridiculous.
After the facing was done, I flipped it around and started drilling it out.
So you can see the wobble there, but that's okay because it's just a rough bore. It'll be a 2.5 inch deep hole, and then we'll bore it out with a boring bar the rest of the way. To get rid of that hole that was uneven that would have messed up the drilling process, we bored it out a little bit before.
After I drilled that big hole to the depth that I wanted it, I proceeded to use a boring bar to widen the hole to the desired diameter. I then filmed the last few passes with that boring bar. I'm getting ready for the final boring of the inside, the final boring pass. So the goal is going to be to go in using the power feed so that it's nice and smooth, and then once I'm close to it, turn it off and hand feed it in, and then back it that way so that I don't scratch the final bore. So here we go. Set to take 50 thousandths off. There we go. Try and pull off the shavings. Recycle all these shavings. I'm gonna melt them down. Really got jammed up there. That's a shame. Cutter's all fine. It's the only time that's happened yet. I need to do a better job making sure to get the shavings out. Well, I guess I'm gonna have to do one more finish pass after this. And I got cut on the zinc shavings, unfortunately. Okay. Now it's going as expected. Okay, now the shavings are coming out the way I need them to. This is about how the passes typically looked. 2.5 inches in is how far the bore goes. Okay, I'm almost where I get. I may as well back it out and not worry about scraping it up because I'm going to have to do another pass anyway. Because I already scraped it up that one time. Okay, so now for the actual final pass. Let's hope this one goes according to plan because I don't have a lot of metal left. Start heating off the shaving controlled way so that it doesn't jam up and I don't have to back it out. Okay, the shavings are falling apart, which makes it a bit harder. I want the shavings to not fall apart so that it's easy to leave them off and pull them out of the container. That's the ideal anyway. Okay, well this is going smoothly so far. Got about an inch left in the cut. Let's hope that inch goes well. Okay. Hour. 3, 4. Okay, now I'm going to hand feed it the rest of the way in. Nice and slow. They were 2.5 inch. I can back that way so as to not disrupt the finish. And there we go. The ID is done. Next, I remounted the casting in the truck such that it was sticking out more. And then I put a large live center into the tailstock and moved it up and pushed it into the mouth of the canister to support that end and also make sure it was turning true. Then I proceeded to mill down the outside.
I realize you can't actually see the cutter from this angle, but you'll at least be able to see the metal as it gets machined. So basically the idea is to round out the outside. So, alright. Off gear. Medium. Okay. Now it'll turn. Start cutting into it very, very lightly. Want this as clean as possible. Okay, now I'm approaching this wider edge. We'll see how this one goes. Seems like it's leaving a very shiny finish. This is looking. Oh wait, let's turn it off. Ooh, that's giving a nice finish on the zinc there. I'm excited about this. Okay, let's do another 10 thousandths. On we go. This will be my last pass. I'm taking 20 thousandths off. Alright. Got to engage the motor. Okay, it picked up some of the shavings, as you can see. That's undesirable. Guess I should have made sure to clear those out. Didn't realize they'd do that. Pile up for long enough, I guess that's bound to happen. Let's see where this is. Okay. Yeah, I'm gonna take one more 20 thousandths pass on this after this one's done, and then I'm basically gonna call that necessarily good. Okay, medium. Lathe back on. Power feed back on. Power feed on. keeps happening. Okay. I mean, it's not perfect. The casting wasn't perfect, but it's surprisingly close. That's very good, and that's definitely satisfying to me. So now let's set this up for the next type of machine operation where we get rid of that part.
To remove that little ridge there that was the surface being held by the chuck, I flipped it around and then used the expanding chuck to hold it from the inside. And then I indicated it so that the end I was machining was turning true, and I indicated on the closest machined surface. I then put a live center on the tailstock and pushed it up against just to give a little bit of support, and then carefully machined it down. I didn't film any of this removal of the remaining ridge on the outside, so the next clip actually shows me working on the bottom. On the bottom, I faced it one more time to make sure that the sides were perpendicular to the base, and then I recessed most of the bottom, only leaving a proud ridge around the edge. And the next piece of footage that you see is of me taking the finish pass on that ridge to get it nice and smooth.
Okay, time for the final pass on the base. Let's see, just gotta get that rim nice and flat and smooth. Cutting only a very tiny amount because it's a finish pass. And I'm using power feed to get it really smooth. This will help it sit nice and completely perpendicular with the sides. There we go, all done. So now the only thing left to do is to cut a little bit of a hole in the middle there to get rid of that nub. Okay, so now it's time to do that little drilling job. Hopefully you can see I've got a tiny center drill in there, and I'm basically gonna drive that into the bottom a little bit to try and yield a better center.
With the body all done, it was time to make the cap. All along, when I was machining the body, I collected the zinc shavings in a bag, and then I melted down the shavings in an identical can to the one I used to cast the body to make a blank of the same diameter, but that was much shorter. I then mounted this up and started machining it down. The problem was that as it cooled, a divot formed in the top of the billet of zinc. So what I ended up having to do was drill out the center and then countersink it and make a magnesium plug. Now, the filming here is much better. I had my iPhone 10, and I was also free enough when I was doing this to be able to film it more, so the following section should be quite pleasant. So here is cap production.
Okay, so update on the cap production. When it solidified, there was a big hole that went deep enough that I was going to have to do something about it. Now, my original plan was just to drill out the part where it was irregular as deep as necessary to get all the irregularity and just have a circular indentation in the middle of the inside of the cap. It wouldn't, it'd be kind of weird, but it wouldn't look bad. But then I found something really interesting. From a previous project using magnesium, I found this chunk of magnesium left over, and it's big enough to make a plug. So what I'm going to do is actually drill this all the way through and then make a plug out of this chunk of magnesium, so it'll look sort of intentional. It'll be a magnesium inlay in the zinc cap, which I think is quite cool. But that does mean I need to carefully drill out the center there and then bore it to the width of the hole that I've already cut. and then finish off the rest of the shape of the cap, and then chuck this piece of magnesium up and cut the plug. Probably make it T-shaped so it sits in nicely. I don't think I'll fasten it in any fancy way. I'll probably just set it in there. It's a decorative container made out of exotic metals anyway, so who really cares? Now let's do this drilling. I'm going to take it slowly because it's chucked up in a way such that it can't really take a huge amount of tool pressure. In fact, that's why I'm going to use only small drills and then bore out the rest instead of using a big drill to get me closer and have less boring to do. Doing it the way I just described is going to be slower, but I mean that's the way it goes. It's just what it takes to make this magnesium inlaid zinc cap. It's surprisingly thick. Now for the next drill size up. Let's get going. I put that last one all the way through. Ugh. Not liking that irregularity. I'm going to try and flatten out that bottom a little bit so that it doesn't go in so rough. So here's how it looks currently. I've been boring out the uneven part to make the drilling easier. I wish I'd done that before I've done the small hole, because the small hole wouldn't be as off-center, and I'll be battling that when I do this next hole, but it won't be as bad, at least because the area around the hole won't be as uneven. We'll just have to see how it goes. This is the last bit of boring I'm going to do before I work on cutting that hole, or drilling that hole more. I don't know exactly how big I'm going to go before I just start boring it. As small as possible. I don't know what the diameter is sort of mandated by this particular boring bar. This is the smallest boring bar I have access to right now, I think. And so I'm going to have to find a way to get it to work with this. So let's finish this cut though first. Let me worry about the logistics of drilling and boring all the way through after I've finished. Okay. So let's pull this back now. Now let's see if I can drill nice and slowly and cut it unevenly. Maybe it'll even out as it goes in a little bit. It's not bad. That's tolerable. It's not great, but it's not terrible. I like how that shaving's winding around the bit like that. That's actually pretty cool. Okay, so if the material is ejecting just fine, so I don't have to back it out. I think I'm all the way through. Yep, there you go. You can see I'm all the way through there. Okay, so let's back this out. Don't think that hole is nearly as off-center as it was. I mean, you can still obviously see that it is. It's wobbling. But I don't think it's as bad as it was. I think drilling it out, it sort of cut unevenly somewhat so that it helped even out the off-center hole a little bit. So this is the next drill size I'm going to use. It's actually pretty big. It'll hog out quite a bit. We'll see if I can make this work conveniently. I don't know. It'll be interesting. I'm going to have to go nice and slowly to get this to go well. Let's see how this works. Shattering a lot, but I'm not putting much pressure on it. It's cutting without requiring me to really put much pressure on it at all. It's really cutting well. Shattering or not, it's like cutting it like butter. Way easier than even the last drill bits. This is really just going through it. This is like cake. Wow, this must be a sharp drill bit. Wow, that was like the easiest drilling experience I've had. That was really, it just sliced that. Let's see. Ooh, that feels very sharp. Okay, yeah, that's a well-sharpened bit. Okay, very cool. Certainly big enough for me to bore it. Yeah, so we're done drilling. great, I can start boring it out. And I don't think that'll take that long. Very cool. Now, none of the sizes on here are really very specific. This is just a random fun thing that I'm making. I do love metal machining. It's just so fun. You can make anything. You can see roughly what I'm dealing with here. Turn off the auto feed, and we can back it out. Then up here, let's dial it in. What's wrong, like 2.1 inch. Go back a little bit. Yeah, that works. Yeah, that works. Okay. Now you can bring this in close and zoom out a little bit. Auto feed back on, and we're cutting. Dial this out another 20 thousandths. Auto feed on. Okay, this is the last boring cut. After this cut, all the boring will be done in this cap. Then I'm going to face the front here one more time just to get it to the final form that I want. Then from there, I'm going to start working on the outside. Then once I have the nub that will go inside the canister done, and the outer part milled to the right diameter, then I will part it off, turn it around, mill a countersink into this bore here, and face off the top nicely so that it's smooth, because parting doesn't usually leave a good finish. It's definitely for rough cutting. So now for the final face cut on the side. Let's see how this goes. Using the auto feed to get a better finish. Okay, yielding a nice cut so far. bevel I'm getting. I think that's probably good enough. And there we go. That inside surface and the face are now all done. So now I'm going to do the sides there, and I'm going to cut a T profile on it. The smaller part will fit into the canister. And then the larger bit will be the same diameter as the outside of the canister, and then I'll part it off. And I'll have to part it reasonably close to the chuck because, well, unfortunately this isn't a very long piece of zinc. Okay, so I've gotten it round, and I wasn't using the auto feed, which is why it was harder to film. In fact, I didn't film because it was going to be more difficult. But now I'm going to use the auto feed for one cut so you can see this particular step in the production of this cap. You can see the rough metal there, and then I've machined it all smooth and round, and it looks really nice. I love that I'm cutting something so clean out of solid zinc. I just get a thrill out of this. Okay, there we go, it's engaging. I'm gonna keep my hand on it just so that I can turn it off as soon as it needs to be turned off. That way I don't run into the chuck. Because guess what, that would really suck. It leaves such a nice finish when I use the auto feed. Just the evenness of the rate at which it's fed is really helpful. So I've finished the outside to the diameter of the original container. So you remember this is the original zinc body. So now it is exactly the same diameter. So the next thing is to machine part of this surface down further so that it'll fit inside the container and make a nice lid. That's what I'm going to do next. Okay, so I've got the nub machined in there. I didn't film it because I was focusing on just trying to get it done. I got it down to the point where it fits pretty easily in there. It's slightly, very slightly looser of a fit than I was hoping for, but it's not bad at all. So I mean, I need it to be able to come on and off pretty easily. That's not bad. Okay, so now what I'm going to do is I'm going to part this off, then stick it in the truck the other way, and finish off the top. Okay, so I am short on time, so I didn't film much of it, but I parted this off, faced the top nicely, and then rebored the hole in the middle a little bit, and then countersunk it to get ready for the magnesium plug. And I just rebored it a little bit so that it would be concentric with the countersink there. It fits in here nicely. It's a really cool container. This is the magnesium chucked up, and that circle you see cut into it is actually wider than the countersink. So
I've got definitely enough material to work with here, and I'm basically going to machine it down and make the plug in a very similar way to the way I made the lid. It's just basically like a little mini lid for the hole in the lid that I had to make because of the casting issue. It appears as though there's going to be a lot of opportunity to use the auto feed here. Now what I'm doing is actually not facing this off. I'm just getting it round in an unusual way. I'm just coming in all the way to the larger than I need diameter, the rough diameter, with each pass. And this allows me to use the auto feed without being at risk of hitting the chuck. Of course, I'm standing here and watching it, but anyway, still, I figured that was a nicer way to do it. So here's the work so far. I've got it round all the way. Now I'm going to face it off. I did one face, but the surface is super rough and unpleasant because I used a less than ideal tool. This is a rounder tip on it, so this one ought to do a better job. And I'm also going to use the auto feed. Zoom a little bit. Ooh, that's a nice shot. I'm really liking that. Oh yeah. By hand. Okay, there we go. That looks pretty good. I'm gonna have to call it quits for today now. Okay, so I've got the nub and rim cut in on this piece of magnesium. So it's mostly done. So that fits in there, you can see. It's the subcap. It's the magnesium inlay that I wasn't planning to make, that turned out to be necessary due to the casting imperfection in the zinc chunk I had to make the lid out of. So what I'm going to do is I'm going to turn it around and mount it on the nub, and then very carefully turn down the sides here, and then cut it to the right height. So I've reversed it, and so now I'm just slowly working through the process of milling down the jagged corners of this magnesium piece. Then once I get it more close to the final diameter, I can start thinking about cutting it to the final size. But right now it's just a matter of knocking down these pretty ridiculous sticking out corners. So the outer diameter is all done now, and I've been working on facing it to the right height. I have that bevel there just to remove the burr so that this slides on nicely. The zinc is a slightly bluer metal than the magnesium, as you can see, which is slightly redder, so I think it'll look kind of cool. So I have finished cutting the magnesium plug to the desired height. Its profile looks like that. I also beveled the edge. It will sit slightly proud of the zinc, which I think looks cool. It fits into the zinc cap very nicely, like that. So you can see on the back there. And then you can see by comparison that the magnesium really is a redder metal than the zinc. The zinc is kind of that bluey color. You can see it on the top as well. And then of course the cap fits in the body like this. And the canister is done. So this is what it looks like from the side. There are those two decorative ridges there. So the bottom looks like. And of course that's what the top looks like. I'm very happy with the way this exotic metal turning project turned out. It was cool to machine these metals. It was cool to see what they're like to work with in reasonably large quantities. Of course I've experienced magnesium before, but I have not machined bulk zinc before. So this was quite fun. It's worth noting that this container is really heavy because the zinc is quite dense. So that concludes the production of the first zinc canister, the first project made out of the zinc that I showed in my zinc unboxing video. I hope you enjoyed. If you did, give it a thumbs up, and don't forget to subscribe. Dietterich out.